I've heard this argument a few times where people are like, oh, well, the AI race isn't a race. What are we racing towards? What is the goal, right? But I tend to step back and say, well, there is a clear goal, actually. Like, if we cure cancer, that is a power law outcome. Whoever cures that, whoever uses AI to come up with some type of cure, the first place is miles ahead of everyone else at that point, right? They will use that to build, drugs to ultimately treat the illness. There's no real second place, right? Like, you would use that to have a power law outcome to then own that ecosystem and drive it forward. But this is true across all different verticals that you can apply AI to.
I just remember that point that it's like this weird sort of, I don't know, fretting around compute no longer being as relevant because training is scaling down.
So that moment was the DeepSeek moment.
Yeah.
And when DeepSeek came out in February of this year, and they did it on an H800, which was a lower power piece of infrastructure that was given to China, because US has export controls on certain type of silicon in terms of flop processing. And so what happened in the market was, when DeepSeek happened, everyone was like, wait, the evaluation benchmarks for the most advanced models in the world, how did they do it on less compute, right? And so the narrative that came into the market was somehow, this incredible research team in China was able to build a model that's just as sophisticated as the proprietary closed models in the United States. What have they done? Now, there was, if you fast forward and once information disseminated in the right way, turned out they used a huge amount of H800s. Turns out there was massive amount of compute that actually trained the model. But the belief was, is training and the forecast estimates for NVIDIA, has it been essentially overestimated? And we can talk through, absolutely not, in my opinion, why it is not the case. But we can talk a little bit about Australia and the power issue that this country faces. I've just spent the last 2 days trying to advocate for that. But yeah, we've still got a long way to go on training compute. And a lot of the clusters, even the most advanced clusters that Microsoft are building, that everyone in the States is building, at highly training focused. I mean, in compute, there's only really three things that matter. There's memory, flops, and interconnect. They're the three things that fundamentally drive AI. In training, you need a slightly different configuration between the GPUs to highly optimize, sort of the way the training is done versus inference more broadly. And so, yeah, I don't think NVIDIA should be worried about compute forecasting. I think their quarter after quarter performance has been incredible, and it's a testament to their product. But generally, inference is scaling much faster. And the reason for that is there's a very small number of sophisticated frontier labs that have enormous volumes of compute. And they're still training, but the rest of the world is really just using those models and open models to run inference. And so that's post-training, fine-tuning, alignment, whatever you want to call it, to essentially take that base model and then, apply some specific degree of data to it to improve for a certain use case, right? And I think one of the big things that's changing now is sort of, in VC, you talk about product market fit or sales market fit. In AI, it's increasingly now like model workload fit, right? Like, Brett Taylor and the crew at Sierra just published an interesting article about this constellation of models, right? There's no one model. It ends up being 14, 15 different types of models, depending on the use case that you're trying to track. And Open Router actually just released a report today on the state of AI, and they go through all of their sort of open model data and talk about how the usage is actually disseminating a lot across different use cases. And so, I think the idea that one single lab is going to dominate all AI, I don't actually believe that to be true at all. You see Anthropic doing amazingly well in code generation. OpenAI is trying to really tackle, it has an enterprise business, but it's really tackling the consumer use cases. Google's trying to use its dominance in search to essentially have AI mode as a new form of search. And so, I don't think that there is one specific thing that's going to unlock or drive people to any one of those services. I think in the end, there's going to be, and enterprise is already doing this, a lot of the customers that we work with, everyone wants lower cost. And so you have to trade off this high degree of intelligence cost, which is what OpenAI have and Claude have, Anthropic. I think Google's in a unique position. We can talk about why they are, because they have a vertically integrated stack that I helped build and many other incredible people helped build. But it just changes the economics, and it changes the focus, I think, for the world between training and inference. So that answers your question a little bit on that.
let's pull on that the Google point. Like, you were there through such a formative time.
Yeah.
And I think the rest of the world, it might seem like they've kind of gotten up off the canvas in the last few weeks. I'm sure that wasn't as much of a surprise to you, having been there. But could you talk through a little bit that journey, your time there, the way that they've gone about this vertically integrated approach, and maybe putting that into context of what's happened in the broader industry in the last 10 or so years?
Yeah, and I think it's a huge testament to Sundar and the broader team there, because for a period, particularly when ChatGPT came out, there was strong criticism that Sundar wasn't a wartime CEO, that he wasn't going to be prepared for this sort of coming wave. I think to people who knew Google, and I was fortunate enough to be there for 7-8 years, they had a huge advantage in that Google has a completely vertically integrated AI stack. So, way back in 2015, 2016, and even before that, with the acquisition of Google ultimately it was DeepMind, became Google DeepMind. Jeff Dean, who's one of the most famous computer scientists in the world, created an enormous amount of Google's search infrastructure, and ultimately was one of the co-founders, which was the ultimate acquirer of Google DeepMind. What was really interesting was he predicted once that acquisition went through, the compounding nature of compute was going to be a massive limiting factor for Google. And so he said, look, we can either continue to buy NVIDIA GPUs, or we can invest in our own silicon. Google has, what is colloquially in the Bay Area known, or Silicon Valley known as NIH, not invented here. And so they have a huge desire to just own everything. Sridhar, who ran the ad business for a long time, was famous for saying, we're never going to run a $130 billion ad business on infrastructure we don't build and own ourselves, right? And so, I think there was an underpinning of, we want to invest in silicon because we believe, if you cast this vision, and you remember, this was way back in 2015, we believe within the next 10 years, the volume of compute is going to be astronomical. It's going to exponentially increase. And that, to Jeff's credit, and there's some other very smart people involved in it, but to that decision fundamentally changed the economics for Google, right? So we look at now in 2025, when ChatGPT first came out, yes, it was like a code red at the company, but the reality was they had the compute. And what that changed for them was, and they already have, incredible history here, is just cost per query is something that matters, right? Like in search, you're sort of looking at, generally a Google search business, it's a consumer-driven business. They look at average revenue per user. If you can drive down cost per query, that's the huge advantage then to ad revenue, right? And so then if you go back and you say, okay, well, Google bet on its own silicon. It bet on, TensorFlow, which was the open machine learning framework that got released at the end of 2015 into 2016. It essentially woke the world up to deep learning in the biggest possible way, right? And what was interesting was Google made the decision at the time, despite the fact that it was already working on TPUs, to build on top of CUDA, which is NVIDIA's software platform. So if you go back and you look at the history of NVIDIA's stock price, you start to see real inflection in their stock price, like in 2018, 2019, which was actually the result of Meta, and they had a machine learning framework called PyTorch, and Google, who has a machine learning framework called TensorFlow, both building on top of CUDA, which became the central software platform for everyone to access their silicon. And so, I think the interesting thing at Google that we learned was they had a stack for TPUs, which was their massive research training clusters that was running advanced modeling and research. They had a stack, an open stack for CPUs and GPUs, which is what was NVIDIA, but it was also AMD. There was Intel. There was obviously still a lot of CPU-related workloads back in 2017, 18, 19. And then they had a stack for edge. And so the belief in the company, and I helped work on a lot of this stuff, was how are we going to run AI on mobile phones, right? And so there's a very famous paper, which is where the attention mechanism came from in the transformer architecture, which is now the primary method of scaling. And actually, the GTP in ChatGPT is generative pre-trained transformers. And so the transformer architecture, which was created by some amazing folks at Google Brain, the use case was, how do we get better translation out there into the world so that when two people are conversing, you can pull out Google Translate and you can run translation, right? that was the original reason for it. And the attention masks that were applied from that were all driven from translation-related use cases. Google chose to open source that, and it essentially changed the world by doing that, right? But it had built this completely vertically integrated stack from the ground up and enabled them to look at inference efficiency incredibly well, from all the way back to that moment when they first open sourced really TensorFlow. I think the most interesting thing though was in 2017, 2018 was the training inference flip. And so we sort of went from this world where it's sort of, well, it's well known now, but it wasn't at the time, that training scales to the size of a research team, but inference scales to the size of a user base. And so as the utility of these models, particularly for ad workloads and even in search in terms of relevancy and ranking and a whole bunch of other things, as it became more critical, the other thing to remember is like YouTube has a lot of product surfaces. It has not only Gmail, predictive text in keyboards, night sight in camera. All of these things we're using different AI models in different ways, right? And so I think what ended up happening was as they started to, particularly for BERT, which was another major sort of architecture that was released, it massively improved relevancy in ad serving. And so Google's revenue just from that model jumped very significantly. And so they very quickly realized, well, we need to scale inference in a huge way. We are realizing that these models are, we've done all this training, but it's actually the serving of these models that's going to be the complex thing.
What time frame are we in here?
So now you're in, 2017, 2018
right.
was when this started to happen.
So still pre-ChatGPT.
Yeah,
really
absolutely.
Pre, like I say, public knowledge of transformer architecture.
Yeah, and I think what's interesting, and this is my personal opinion, folks may disagree with me. One of the interesting things that might not be as well known was there was an I/O where, and you may remember it, but there was an I/O where Sundar stood up, and the demo was this like calling a restaurant. And he basically got on stage and said, look, AI is getting advanced enough now where you can just call a restaurant. It can negotiate with, the person who picks up the phone and book, a reservation at a table. It did that. Certainly in the US, when that decision went ahead, the reaction from the global media was very negative. It was, AI is going to take everyone's jobs. This is the end of sort of, very strong visions of Terminator, those type of things. And what it meant was, internally at the company, there was a pullback from that moment, actually. And so what ended up happening was this idea that we should be all open sourcing all this stuff, the idea that Google should be as public about how advanced AI is becoming, actually became more constrained in some ways. And what was amazing was, and this has been, I think, well publicized now, but around that time, there was already an internal version of what the world knows as ChatGPT. And I think the retraction that happened because of the media pressure with how advanced people thought Google was, in some ways, you can think of it as the risk profile of the company changed. And so rather than being more proactive and say, hey, look, we have this new chat medium, why don't you interact with it? That it would have put them in front way back then, probably. They chose not to do that. And then as a result, the incredible team at OpenAI were like, hey, here's this thing, what do you think about it? And I think the world woke up to this sort of multi-turn chat experience that happened in 2022, and I think everything's changed since, right? Like you're talking about almost more than $1 trillion of value creation almost since 2022 to now, which is insane period of to think about. It's only like 3 years, less than 3 years, and so I think that is that's sort of the journey through Google. And so there's many observations on how the software stack was created. Then if you jump forward to today, where we are with Gemini, Google now has a huge advantage. I think everyone's sort of looking at Google as they have looked at Apple and said Apple has a completely vertically integrated stack, has its own silicon, has its own operating system that enables us to drive an incredible user experience. They have an amazing team working on that. And you look at all the other companies like Microsoft and OpenAI and Anthropic, they're all relying on the NVIDIA stack, which is why that NVIDIA's stock price has driven so high. I think Anthropic has an interesting relationship with AWS. They're building their own silicon, but Google's the only company through that whole period. And even after ChatGPT came out and there was a question about its dominance in search, are they going to fail? And I think the reality has been where we are today, and literally sitting here in December 2025, in the last month, they represent now 20% of all gains in the S&P 500 across the course of this year, which is mind-blowing in some ways, right? And it is simply because they took a bet on building TPUs and then a full software stack for TPUs that they could scale. And what everyone's anticipating is that the cost, not only of training for them, but of inference for them, which is a much bigger chunk of the cost, is going to be so significantly lower that it's going to be difficult for these other sort of frontier labs to compete in the long run.
I feel like that's a very interesting segue into what you're now building with Modular. It feels like really the name Modular almost is like the antithesis of a vertically integrated stack, but in a lot of ways it feels like there are lessons that you've learned from how Greg went about it. And I don't know if this is the right framing, but it feels almost like, how can you almost democratize some of those advantages of verticalization to broader builders? And I mean, I'd love to lead off with a little bit about what you're building, and then we can sort of get into that.
Yeah, so that history, I think it's important because when Chris Latner, who's my co-founder, is an amazing engineer. He's done the Swift programming language. He's built an open platform called LLVM, which is a lot of the world's compiler infrastructure. We met at Google. He was brought in to help bring up the TPU software stack. So we had this sort of like 6-7 years of product research that we'd seen. Okay, well, if Google has the most advanced company arguably in the world for AI has 3 vertically integrated three separate stacks. To the world, it appears that they're integrated, but they're actually not. They have, this TPU stack, this CPU, GPU stack, and this edge stack. How is everyone else going to be able to compete, right? And so we said, what if, and then to the outside world, most of, 95% of external data centers are NVIDIA, right? And so there's huge consolidation very much in data center infrastructure around the world. And so we said, a huge part of that is the software layer, right? Like if you could free the software layer, what would that do? So that was one thing, that was sort of one long-term arc thesis that we had. I think the second one was that the future of superintelligence wasn't just going to be in data centers. It was going to exist in data centers and at the edge. Like it is natural that that you train these models and you interact with them. And today they're, sort of autoregressive LLMs. So they very, look at their history to sort of predict what's next. But, in the future, the reality is AI has to exist everywhere for it to fully, at least in my opinion, to get to some degree of superintelligence. It has to exist in our real world, not just in, large bodies of pre-trained text corpuses that drive it, right? And so, if you believe that to be true, then you need a platform that goes from data center to edge. That doesn't exist effectively today. If there's more hardware out there in the world, that creates more competition, and that would be great for everyone. It would change sort of the economic equation for training and inference. If you have one company dominating silicon, then it's natural that prices, just supply demand are going to skyrocket for that specific player. If you're able to change that through software, it would lower the barrier, right? And so, what is Modular? There's a long way of saying what is Modular. Modular is essentially a unified compute platform. Our goal is to become, in many ways, a hypervisor for compute. The reality is when you go and talk to developers today and you go out there and you talk to people about, hey, you want to deploy machine learning, the secret is no one cares about the hardware. Most people go, I have a latency target, I have a throughput target, I have an accuracy target, and I have a cost target. Help me, right? And, I just met with a bunch of customers even here in Australia. That conversation couldn't be more true. No one comes into the conversation and says, I must definitely use, TPUs or NVIDIA chips or AMD chips. That's always like the sort of the result of those 4 inputs. And so what is Modular doing? It's essentially, that playbook. It's saying, look, if we can build a common operating model, if we can make it easy for hardware developers around the world to plug into this, this platform that we're building, then developers on top of that essentially get all the benefits of that hardware. We can help them realize, the cost equation, the TCO for their use case. And, for developers, it's a consistent development experience. They don't have to, swap from their CUDA operating model to their ROCm, which is AMD's operating model, to Google's Stack operating model. If you want to go out to other types of silicon, each of those hardware vendors has their own software. And so it's very hard to get portability between any of the software. And so, we just sort of said, well, in this new world, if there is a common, portable layer that doesn't sacrifice performance, is that an interesting platform to build? And I think the answer is yes.
It sounds like kind of an outrageous thing to say in a world where so many of the most valuable companies, including the most valuable company in the world, are hardware companies. But it does feel like it is sort of the extension of a broader trend in technology of software commoditizing hardware over time.
Yep.
Is that the way you guys see it? Like, this is a continuation of that arc. GPUs kind of should be no different to generations of hardware gone by. Maybe in fact more reason to, given sort of the scale we're operating at and the opportunities for efficiency, both cost and performance.
Like, a good analogy to apply to it is if you go back to, say, when cloud first started, right? AWS came out with EC2 and storage, and everyone jumped on it. All of a sudden, everyone started scaling. And then very quickly, everyone was like, well, hang on a second. We don't want to just have one cloud provider. We want to be multi-cloud. And then, obviously, Microsoft released a cloud platform. Google released a cloud platform. And, you have these and then, Oracle came along as well. And very quickly, everyone says, hey, look, I want a multi-cloud approach. I don't want to be bound onto one cloud platform, right? And so that's exactly how, the ecosystem has evolved. It's a funny conversation because some people also say, well, when you go and have a conversation with any startup, are you going to move off AWS or are you going to move off GCP? Everyone's like, no, I'm not. But I want them to think that I can. And why? Because they want to lower the cost that they pay those clouds. They want to be able to say at any point, if you're not going to give me better pricing, then I'm not going to stay, right? And so if you jump forward to where we are today, in some ways we're back, NVIDIA is AWS of, 10, 14 years ago when they first released cloud. And really where we are at the beginning of, in some ways the beginning of AI is you have a single very dominant hardware player who is powering an enormous amount of workloads. They have an amazing product and they're reaping the benefits of it. But what everyone is now doing is saying, on one hand, you can't stand up at Wall Street on Wall Street and say, look at our 70 to 80% margins. This business is amazing. And then equally go back to customers and say, are you happy about that? Because naturally those, and we hear this from everyone, they're saying, well, no, we want to pay less for compute because we know, if you cast your eye forward 5 years from now, just everyone's going to be consuming a lot more compute. And so as a result, now everyone's like, well, how do we have a portable approach to hardware? Because if GPUs are the, essentially the underpinning firepower of AI or silicon is, and GPUs as part of that story, how do we sort of have this approach where we can build, be on a platform that enables us to easily move across different forms of silicon and not be locked to one provider purely because we want to get cheaper compute, right? And so I think that's sort of the tailwind that we see in the market. The headwind that, we think about a lot is NVIDIA had 95% market share. And so there's supply chains, there's geopolitical implications, there's power issues, there's all these other things that make scaling this challenging. But I think, the most interesting part is you have certainly the three largest clouds in GCP, in Azure, and in AWS, all building their own silicon. And they are all telling customers, look, NVIDIA is great, but you can also use our silicon. And so that's another huge tailwind because, and I think the NVIDIA team say this publicly, we have a lot of competition. Even our largest buyers, all the hyperscalers, which are buying huge amounts of NVIDIA compute, are all actively trying to get people onto their own silicon. And so, to us, that is a general tailwind to say, well, if our software platform can deploy on each of those forms of compute, then it makes it very easy for you to go between an NVIDIA chip, an AMD chip, and Google TPU chip, and that's sort of the longer vision that we have. And then not only that, our belief is eventually it is going to go to the edge, right? Like, you are going to have a customized, personalized AI that sits on your phone or in your glasses or in a watch or in your shoes or in your clothes. And the reality is all of it needs some form of compute to power that. And then you need a software programming model to be able to actually make interesting programs to execute in those environments. And so all of that to us, is this long arc of AI and of how you need a unified programming model ultimately to get there. And so I think that's how we sort of see, where the market's headed.
You mentioned earlier that you've been in the US for 13 years
Almost
now?
14.
Almost 14 years. We met over in California earlier in the year. I think it was very stark. You walked out of your office with a pair of thongs on, We went and got a flat white from an Aussie cafe.
That's right. Yeah.
So you clearly haven't lost the Aussie identity, but I'd just be curious, like as a VC in Australia myself, you're now back here, you've been here for about a week or so. How does it kind of compare to 14 years ago? What are sort of like any thoughts and reflections on the evolution of the Aussie startup ecosystem?
It's interesting. I think this sort of gets a little bit to like why, and I was asked this recently, why leave Australia, right, in the first place? There wasn't really, at least in 2011, 2012, when I left for the United States, there wasn't, I laugh, I had an angel conversation back then where one of the angels was like, I'll give you $500,000 for 50 or 60% of your plus of your company, right? And you sort of, I think that it wasn't necessarily, it's not necessarily a dig at that person, but it was like, that's insane. I'm not going to, work 7 days a week for the next, God knows how long. And you've taken 50% of the company for $500,000, right? And so, I think generally back then, at least, it felt like there wasn't really a strong VC community. There wasn't really a lot of liquidity in the market yet. Now you jump forward 14 years, there's incredible companies now that have obviously gone public, like Atlassian, Canva's doing incredibly well. There's just a lot more startups that have been successful, in Australia. And so that begins to create a more liquid ecosystem. There's VCs like you guys now and others who are, injecting capital back in the early sort of startup community. Like, I wish that was the case when I went to the US, right? But it wasn't. And so, when I landed in Silicon Valley, it wasn't easy either. Like, it's not easy, just on a personal level, it's not easy to say goodbye to everyone, your family. I just actually got married. And so, even then, my wife and I, spent a year apart basically because I was over in the States sort of pursuing this crazy dream. And so on a personal level, it's really hard. The US system also isn't, that friendly to people coming over, right? Like, no one will give you a credit card. No one will let you have a bank account. It's very hard to just, get going as a person in the country, as you sort of go through that process. Like, it wasn't easy. And I think every founder has their own, entrepreneurial journey. I tend to just think of it as a series of step functions. You think you're on your way up, and then you get smacked, and then you're on your way up again, and you get smacked. And so, for me, we eventually got this first company off the ground, which was a food delivery company. It was a competitor to DoorDash, actually, which is now obviously incredibly successful. My co-founder and I at that company, we really struggled. We knew no one. We were lucky enough to get a couple of angels who, over there, they were like, yeah, I'll give you 250,000 US for fractions of the company, right? And so the risk taking was radically different. And a lot of that's just because the capital flows came out of Meta and come out of Google. And so people sort of just see this as look, you're building a really interesting product. And if this takes off, it can be huge. But look, most people take the philosophy there, certainly at the time that we raised money, I think this was true for years before it, we are giving you this seed money and not expecting $1 back, right? Like, most startups fail, we get it. But that's also part of the Silicon Valley journey, right? It's rare to find founders who just start a company and they're successful all the way. More often than not, it's the stories you don't hear that ultimately come out, like, oh, well, I founded 2 or 3 before and, none of them worked, and I learned all these lessons, and then I went and worked at a successful startup, or I went and worked at a large tech company, and I began to learn the ropes. And so then finally I bounced out and I started a company, I was successful, right? And so I think it's an important lesson for folks to understand, like, the biggest thing is don't give up. Right? Like, even after our company, we were lucky enough to sort of to go into Google, and that was sort of really a hiring process for us. They came and said, look, you guys are doing some interesting work. Food delivery is a terrible space. The margins are shocking. Back when we founded it, very quickly in the US, there was this sort of question of, are you a contractor or are you a employee? And so most VCs turned around and were like, this is terrible. And so for us, you burn, we spent 3 years, 7 days a week, trying to build this company. We had raised some money, but it was just really tough. And so as a founder, in the end, you do hit burnout. You do hit, like, is this the right path? Am I working on the right things? But I think that, and at that point there was, my wife and I were very much like, should we just go back to Australia and, throw in the towel? But I think there was a belief of, look, there is such an incredibly concentrated group of people in Silicon Valley who are smart and who are talented. If you stick with it, you never know what's going to happen. But I think you need to learn some of those lessons along the way. You need to be able to say, look, if I fail, I'm willing to hang around. I'm willing to go and learn from other people. I'm willing to find mentors. I'm willing to learn from the things that we did wrong. And then ultimately find something that you're both, I think there's, an often misconception you have to be super passionate about what you work on. I think you just have to be really interested in what you work on, such that you're willing to do it 7 days a week for at least 5 to 8 years, right? Like any VC that certainly in the US that's going to give you capital for your business wants you to IPO. And I'm sure you would say the same thing. You give founders here, money. You invest in probably different companies around the world. The goal is IPO. The goal isn't just to get like a 2x or a 3x return. That's not success. And so, are you willing to commit that long? Because I think a lot of founders sort of look at these companies like YouTube, they were acquired in 12 months and they all made a bunch of money and it was amazing. But that's not why they started YouTube. They started YouTube because they really believed in building a video platform and then trying to enable people to upload it and just get distribution out in the world. And it took off way faster than they ever anticipated. And they became successful. I think you've got to look at it, that they're just all the outliers and they're in some ways, the Tats Lotto wins in terms of probability. But really, most people go through at least 5 to 10 year journey for their companies. And you have to be willing to spend that long giving it a shot. And if you're not, I would question, is entrepreneurship the right thing for you? Because if you're not willing to commit to those type of timelines, then you can never actually get to the point of success. Like you look at Atlassian in this company, in this country, it's like a 20-year-old company almost. You look at Canva, it's now 10, 12 years old. Like these are long arcs. It's not like it just happens overnight and then everyone's, amazingly successful. It takes a lot of time to build something that's important in the world. And so for me, at least, what makes America unique, and, I certainly hope Australia can, and I think it's beginning to get there, but, it needs a lot more investment too. There's just, America's always had an incredible vision at the top of the American dream, right? It goes all the way back to Kennedy and before with big things like we're going to the moon, these big objectives, and it inspires people globally to go there and be like, I want to be part of that vision for humanity moving forward, right? And so I think, when I look at even our friends that we've developed over the last 14 years, they're from everywhere around the world. We have, friends from Israel, friends from India, from the United Kingdom, from Switzerland, from, just the geographical diversity is insane. I think that's the thing that makes it very interesting. I think the thing that's also now catalyzed, particularly San Francisco, back to sort of this mecca center again of technology, is just most of the research labs came from Google, came from Meta. So, a lot of the founders that have gone off and created AI startups, cut their teeth at Google Brain or at DeepMind, or they were part of, FAIR, which is Meta's research. All of, those folks are who have subsequently then diffused out into the startup ecosystem and all gone and created companies, right? And so the question to ask in Australia is, how do we, or how does the country attract some of that talent here, right? Like, I think, you have what makes Australia great is it has a stable political climate. It's not as, polarizing as the United States. It's a wonderful place to live, has amazing healthcare, awesome schools, like has every ingredient fundamentally that should make the country incredible for entrepreneurs to come here and start companies. And now it's beginning to have a liquidity ecosystem where people are willing to take more right angel checks and partner on, making these companies successful. And so I think it's a case of trying to bridge the gap between, Melbourne, Sydney, Brisbane, other places, and Silicon Valley. How do you tie that arc together? I think is actually part of the success story that has to happen for Australia to continue to build amazing companies.
Yeah, it's interesting, like that point around the flow of capital when you were there in the early years, and a lot of this angel capital that was coming out was sort of because of liquidity events at then Facebook and Google. Yeah. And I think we're sort of in the early innings of that here. Like I do think it takes almost 10 plus years to like build to get the flywheel to start turning. And we're seeing that at Airtree. We're starting to back founders for the second time, founders that have been in fund one and now saddling up and starting a company again, like you, got crazy enough to go again. But it's interesting to like kind of contrast that to, you know, where we are on the journey relative to the US, and it feels like some encouraging signs.
Yeah, I think the other thing that Australia has, and I spent the last few days talking about this extensively, like the decision in this country to invest in superannuation and the $4.3 trillion that sits there, you know, that is pretty incredible amount of capital sitting for 25 million odd plus people, right? You know, I mean, that is like the envy of the world in terms of, you know, a capital pool that is sitting there to be invested. But the reality is, like, a lot of that money, even now in the AI boom, is being sent and invested in companies who are building AI infrastructure in other sovereigns, right? And so to me, that's sort of insane. It should be, yes, we have this incredible pool of capital. Yes, it is invested on behalf of Australians. Why aren't there these big sort of, you know, I refer to it as a Manhattan Project. Why is the government not declaring that we have a huge opportunity in this country. We have a massive amount of land. We could build and supercharge power in this country. We could build lots of data centers. We could act as a fundamental, you know, APAC superpower for the rest of the region, because they're all landlocked. They can't build data center capacity. They can't build energy capacity. And we don't seem to be doing anything like in terms of, and it's probably not fair to say anything, but we aren't acting with enough urgency to realize the opportunity. And so, you know, for me, I just wish there was more action in that regard. I wish there was more capital allocation. I wish there was, you know, a vision set from the government that's, hey, we have an opportunity to be part of the AI race, and we can be the, you know, sort of the, provide the picks and the hammers in the rush for gold, knowing that the compute is going to be consumed, because ultimately, you know, AI is going to affect everything and you need compute to do it. And so, you know, I think that as a vision has to come from the government, right? And, you know, I'll act as an antagonist towards encouraging them to do that. But I think that is something that that is missing. And I think if you cross correlate that, you know, to President Trump and the administration in the United States, you know, I think what they're at least trying to do is to say, we are a technology economy. We have, you know, now the Magnificent Seven companies, all technology companies, who basically are, you know, now 30 to 40% of the S&P 500. They represent, you know, a huge component of the success of America, right? And rather than not setting a vision, you know, they've appointed, you know, an AI czar. There's deep industry involvement between, you know, all of the frontier and AI companies and government. It's, you know, there's a whole strategic and national security standpoint on how AI is going to affect the, you know, the future of America and American citizens. And so, you know, I don't see Australia as aggressively coordinated as what you see in the United States, despite the fact that we have, you know, arguably $4.3 trillion. And even if you say there's only, you know, 1/43 of that, which is, you know, a bunch of money that we could go and allocate towards some infrastructure as a big bet, it just doesn't seem like Australia's leaning as hard as what the United States is. And so, you know, to me, I think it's just a huge missed opportunity. And I think the urgency needs to be, you know, radically accelerated for us to take advantage of it.
It's interesting, the US example. If you look at some of the announcements even in the last week or so,
Sure.
with the Genesis project, and not only is it this like top-down sort of tech policy, but the coupling of tech and energy policy and how inextricably linked those two things have kind of become in AI.
Yeah, and I mean, it's interesting. I was on a panel, you know, the AEMO, the Australian Energy Market Operator here. You know, they've said over the last, so this is sort of a really interesting stat. In China, you know, they've built, you know, if you look at what is their energy capacity at the end of 25, it's about 4,000 gigawatts of power. In the last 2 years, they've brought online almost 700 to 800 gigawatts of power, just to sort of showcase, you know, how much they're bringing online, right? And if you view ultimately at some point that AI just goes back to how much power we can shove at silicon and scale it. And what's incredible, you know, about it, and I'll contrast it to the United States and Australia. What's incredible about it is 56% of that, between 50 to 60% of that power is renewable energy. It's not like they're just burning coal. They are heavily relying on renewable energy, right, in the country. The United States in the last 2 years has brought on about 100 to 120 gigawatts in the last 2 years, right? So, if you compare that to China, it's like, 1/7 almost, right? And then if you go down to Australia, Australia has brought on between 10 to 15 gigawatts in that same time period, right? And so what makes no sense is, in this national AI plan that recently came out from the government, they're sort of claiming, there's $100 billion worth of data center infrastructure. But that $100 billion worth of data center infrastructure from private, so from hyperscalers and others, requires at least 60 to 70 gigawatts of power to realize that amount of capital investment in data centers. But the Australian energy market operators saying like there'll only be 6 to 10 gigawatts brought online. So the gap is enormous. Like it's not even remotely close. It is huge in terms of what this country would need to do to fully realize the opportunity. And I think there's a lot of other strategic countries around Australia who are looking to us to say, well, where are we going to get our compute? As sovereign states, where are we going to be able to go and train models and be part of the AI future? And they look at Australia as, well, you have all this land and you have all this money and you have all the right ingredients, but it doesn't seem like you're doing the right strategy to realize the opportunity. And so, I think there needs to be a revolution in energy. I think we spend far too long arguing about types of energy. We need all types of energy, right? I think, and this is controversial, at least in the United States, many of the hyperscalers are now bringing nuclear power back online. Microsoft bought 3 Mile Island and they're bringing that nuclear power plant back online. This idea of sort of small modular reactors is becoming a bigger thing, but it's not just nuclear. They're bringing on renewables, they're bringing on coal, they're bringing on everything. Because the reality is, in order to realize the opportunity, in order to say we want to be at the frontier of super intelligence, we ultimately need that amount of power to be successful. And I've heard this argument a few times where people are like, oh, well, the AI race isn't a race. What are we racing towards? What is the goal, right? But I tend to step back and say, well, there is a clear goal, actually. Like, if we cure cancer, that is a power law outcome. Whoever cures that, whoever uses AI to come up with some type of cure, the first place is miles ahead of everyone else at that point, right? They will use that to build, drugs to ultimately treat the illness. There's no real second place, right? Like, you would use that to have a power law outcome to then own that ecosystem and drive it forward. But this is true across all different verticals that you can apply AI to. And so, there are these objectives, there is this goal-directed behavior that we can point towards specific use cases where the outcomes are actually, massive in terms of success. And so, to me, it seems awkward that Australia is not willing to throw its hat in the ring and be a bigger part of that opportunity. And by the way, it's not just me saying this. There's a lot of people, who are echoing the energy challenges. And I think Australia just needs to do more to be part of it.
What would you do if I can put it back to you as like,
yeah,
you're running the show for at least a couple of years. What would you do? Like, what would you start with? How would you think about, how relevant comparative advantages are?
Yeah, I think there's a few things, right? Like, there's been I can't quote the stats, but there's been a bunch of surveys generally that Australians fear AI, right? That they view it as it's going to take our jobs, or that it's going to take over our world and make it less safe, right? If you look at the history of technology, the people who jump on technology trends end up having an outsized benefit over time, right? And there's a famous law, Amara's law. We tend to overestimate technology in the short term, but underestimate it in the long term, right? And so, one of the first things is, I think people have to understand that AI is actually a huge benefit and that they're using it everywhere. If you have an iPhone, congratulations, you're using AI literally every single day. When you type an SMS message, you're using AI because there's predictive text. When you take a photo, you're using AI because it's stitching together, multiple layers of photos and then, changing the lighting. Like, you are already using the technology. When you open up Netflix or, you look at any video service, you're already getting immense recommendation systems that are powering what you see. You see something different to me, right? And this is true of search. This is true of everything. And so, the idea somehow that people aren't using AI is just not true. I mean, almost everyone that interacts with, the digital world is using AI. And so I think part of it is public awareness. Part of it is making it safe and making people understand that, there are this technology in certain verticals is actually wonderful and we should immerse ourselves in it, and it's to a huge advantage. So that's the first thing. I think the second thing is the country needs to set a vision for how do we participate in the AI race and what's our role, right? I think the idea that we act fundamentally as an ally to at least in my opinion, the democratic values in the West that we see as an important, strategic player. United States is clearly the leader in it. It has all the frontier labs. It has all the compute. It has talent density. There's a view of the world where if the United States develops super intelligence, who do they share it with? Well, I certainly hope they share it with Australia, right? And I certainly hope Australia has the infrastructure to run it, right? And so, I think that's a second part of the approach has to just be, what is our national approach to energy? What is our national approach to data center build out? How do we realize it faster? Who's involved in it? It has to be driven from government, but it has to also be driven with, in coordination with private industry. Those two things have to come together to be successful. And then I think there's just a huge part, generally, separate from awareness, separate from infrastructure, on training, on making people understand, yes, there's going to be some areas in the world where AI, I call it AI stratifies. So there'll be people who, for example, you want a neurosurgeon using AI. In that industry, they're always going to be in the loop. They are absolutely going to continue to that their specialization is enhanced because of AI, and that's not changing. But if you are someone today who is copying rows from an Excel spreadsheet from different columns, yeah, you're going to be displaced. That role's not going to exist. And so the reality is, how do we train that group of people to do something different? And the reality is, if you believe that AI is an expansionary force to economic productivity, then reality is organizations should be able to shift some of, a large percentage of people who are working on one thing today to new areas of productivity inside their organization. That's a huge another part of it. And so, look, that's like 3 major points in my opinion. I'm sure there's a lot more, but I think that's where, Australia, and this at least the national AI plan that I saw, there's just not enough capital allocation to realize anywhere near the level of change that the economy is going to go through, that the country is going to go through, at least in my opinion. And I'm an antagonist, so I appreciate that. But
this is why we're excited to get you on. You assure me you'd been delivering hot takes.
Yeah, that's a hot take
week to the government.
That's a hot take.
That's maybe just to close out. I'd love to. We talked about a bunch of sort of like, I guess, the bottlenecks to proliferation of AI, and a lot of them are sort of intrinsically linked. Like some of the things we're talking about at the beginning around efficiency are also highly relevant in that energy conversation. You've talked about what you call the quadratic curse and sort of what that implies is for the need for energy. I'd love just to like wrap up with kind of like, I guess, how you see the role for Modular going forward.
Yeah.
Which of these bottlenecks you're going to pick and choose to sort of focus your attention on, and the extent to which you kind of see the next 5 to 10 years in AI playing out.
Yeah, I mean, I think it's an interesting question because we can talk a little bit about our strategy, but there's also the sort of the known unknowns, and then what may transpire completely separately. If the world continues along the transformer arc, and there's well-known and continued research on the efficiencies that you can draw from large-scale inference, particularly is where we're focused, reinforcement learning and fine-tuning that's attached to that part of the stack. I think when we talk to customers and we talk to developers, what they want is a simpler deployment experience. What they want is a simpler programming model. What they want is the ability to move across compute to lower their costs. So those are all the long-term arcs that we continue to listen to. We believe we're on the right side of truth in terms of building software that continues to realize gains for people in that way. And we work with customers where they're using different, very fragmented software today. They have something in their cloud infrastructure. They'll have a different piece of infrastructure for model serving. Then they'll have a different low-level sort of underpinning infrastructure that whether they're using NVIDIA's chips or AMD's chips. And so they just run into they run into dependency challenges. They run into deployment challenges. There's just there's fragmentation all across the infrastructure. And so when you unify it, that takes a long time to build that infrastructure, but you get a lot of advantages because now you can just verticalize the entirety of the stack. And we literally saw this at Google, like we talked about at the beginning. And so for us, we work with very sophisticated organizations around the world. They have massive inference workloads. They increasingly want us to tackle every layer, the cloud layer, this, the sort of direct model engine layer, and then all the way down to, highly optimized, low-level sort of kernel infrastructure across these different pieces of silicon. And so, I think as the world continues to deploy more and more inference, if you believe that that's an exponential curve, and that we're really today at the very beginning of the scale of this, that's a huge tailwind. Like 5 years from now, I expect the amount of inference that we're deployed globally to be 10, 50, 100x of where we are today, right? And so, to us as an infrastructure provider, we want to be able to ride that curve very heavily. We want to help companies and developers be able to deploy more AI, fundamentally, right? Like that's our belief. And so, with that comes, economic headwinds for our company. We obviously, charge on dollar per token basis, which is the currency, and we can also deploy in different clouds. And so that's how, our business is going to grow into the future. And so, yeah, I think the one thing that can change, obviously, so if you go to what could be different, I think there will be a lot more proliferation of edge-based compute. So you are going to go from data centers to models that now execute on your phone, and you'll run a lot more computation locally rather than in the data center. There could be some new model innovation that completely changes the way we think about how, the transformer architecture in terms of the LLM context is deployed. That could radically change, either in the negative sense requires even more compute, or in the positive sense requires, way less compute. One of the interesting observations that's happened so far is when thinking tokens came out, although the cost of inference is declining, when OpenAI released sort of their thinking-based model at the end of last year, and then DeepSeek came out this year with thinking and reasoning tokens, it exploded the volume of compute, right? And the great example there was, you would used to with LLMs, when ChatGPT first came out, you would say hello, and the model would just type back hello, right? Now, when you say hello, you get the user has said hello. I wonder what the user's feeling. I hope that they're feeling okay. How should I respond to this? So the volume of output now, the volume of sort of decode tokens that's happening has grown, exponentially as well. So even though costs have come down, the volume of compute has exploded. And so I think that is only going to continue, because I think what people are seeing is, increasingly there's agentic workflows that are sort of tying more and more and more compute flows together, which just continues to generate more and more and more tokens. And so, we see that generally as, as a huge tailwind, but you don't know that there's not going to be some massive model change, or, we come up with a better understanding of the human brain. And so that changes somehow the way we create, neural networks. And, it diffuses in a different way. And that could obviously then radically change the landscape for inference. It could radically change the landscape for training. But as our understanding of the space is right now, and as our arcs are towards, we obviously spend a lot of time with very advanced research teams at the absolute cutting edge. We still sort of seem on a very massive compute arc for the longest period, I think. And I just don't see that changing, certainly in the next 5 to 10 years.
That's a pretty good place to leave it.
Sure. All right, awesome.
Thanks very much, Tim.
Yeah,
We appreciate it.